So now when we talk about the solubility of gas in liquid, that means in this case gas is going to act as solute and liquid is going to act as solvent, as we did in this case, that is the solubility of solid in liquid. So now we have the second case, that is the solubility of gas as solute in a solvent as liquid, right. So what we see that some gases are more soluble in the solvent or some gases are less soluble in the solvent. Like I'll state it with an example. When you see in water bodies, suppose I have a water body here. So here I have this thing phytoplankton, I have this thing the aquatic organisms. So what happens, what do we see, that oxygen gets dissolved in water. Oxygen is actually dissolved in water. And what is the source of this oxygen? Obviously these phytoplanktons which are present in the water, right. Those submerged plants which are present in the water are the source of the oxygen. So that means this oxygen is liberated by them and this oxygen is utilized by the aquatic organisms. In the meanwhile it is present dissolved in a dissolved form in water. So what happens when we see about its solubility, so it is slightly soluble. We cannot say that it is highly soluble, it is slightly soluble. But if we talk about hydrochloride gas, it is highly soluble in water. It is highly soluble in water. So as these two are gases but their solubility is somehow different in the same solvent, so that means solubility is different for different gases when we dissolve them in different liquids, right. So that means we get to see a variation that some gases are more soluble and some gases are less soluble in the given solvent. So what is actually the factor which is responsible for that, or you can say that how these solubility can be increased or decreased. So let us explain you the most important effect, pressure effect. Pressure factor plays an important role when we dissolve gases in a liquid. Pressure factor actually plays an important role when we increase the pressure. I just stated you with an example. Again I am doing this for you. Suppose in this container I have liquid and here I have gas molecules and here is my piston. I am not applying any pressure in this case, in A case. Now what happens? I just make the piston move downward. So that means piston is now pressed to this position. So what happens when it moves? It makes these gaseous particles dissolved in the water. So that means the pressure plays an important role. That means if we increase the pressure, the solubility of gas will be increased because gases are highly compressible. You know that. There are large number of vacant intermolecular spaces actually which are present in the gas molecules. So when you apply the pressure, that intermolecular spaces get decreased and that gas gets dissolved in the liquid. That is what we want, right? We want that a gas should be soluble in the liquid. So we can do that by increasing the pressure as we did here, that we just move the piston down because it is applying the pressure. So that means it is making the gas molecule soluble in the given solvent, right. So that means pressure plays an important role. See, you get to see this pressure effect in your daily routine also, right. You all relish drinking this thing, cold drink. So I am just going to make a Coke bottle for you first. So let's say this is our Coke, right. So it is filled with Coke. I am just going to make the drink with red. So you get to see that this Coke bottle has cold drink like this, right, this way. Now what happens when you pour this cold drink or a Coke, whatever soft drink I am talking about. So when you pour, and you know that before I tell you this thing, I just want to know that whether you know or not, that what is Coke actually? It is the carbonated drink, that is the carbon dioxide is added in the water. Carbon dioxide gas is added in the water. So it is an example where you can say a gas is dissolved in a liquid solvent. Gas is dissolved in a liquid solvent, right. So this is what you get to see in a Coke bottle, right. But when you pour this Coke into a glass, so let us make glass first. So this is my glass. So when I am going to pour my Coke into this glass, what I get to see that yes, this is a Coke obviously. But you get to see foam here, you get to see foam on the upper surface, right. But when you saw in the bottle there was no foam, until unless you shake it, right. So when you are not shaking it, you have just bought a bottle from the market and you have just kept it, you are not going to see any kind of foam. But when you pour this Coke into a glass, what you get to see that there is a foam on the upper surface. You know that what actually is that foam? Nothing but the carbon dioxide gas. So what happens actually, when you have just, when we add Coke into the bottle, it is tightly stoppered. It is tightly stoppered. That means we are increasing the pressure, and when we increase the pressure, carbon dioxide solubility in water gets increased. So that means it gets highly soluble in water. But when you pour this into glass, what happens? That means you are decreasing the pressure, because we have just opened the you can say the cap, right? So when we just open the cap, that means we are releasing the pressure, and when the pressure is released, we know that on decreasing the pressure, the solubility of gas in liquid decreases. So that is why this foam actually indicates that this is a carbon dioxide gas which is just moving up, right? Because you know that the gases have the ability to escape, right? So that means when they are escaping, they are making the foam on the surface, and that kind of foam you don't get to see on the Coke bottle. So this is what is the pressure effect which you can see in your daily routine, right? So this is actually a pressure effect. Now we have a law which is actually based on this pressure effect, because as you saw that pressure plays a very important role. Temperature also plays an important role, but if we compare both the factors, pressure is playing almost a very important role in the solubility of gas in liquid. So we have a law given by Henry called as Henry's law. Henry's law. Obviously it is clear that this law is actually indicating the solubility of gas in liquid. It is indicating the solubility of gas in liquid. So this is what is the Henry law. So what is Henry law? What Henry actually states by giving his law, he actually states that on increasing the pressure of the gas, that pressure or external pressure, or you can say the pressure which is external pressure which we can exert, right? So on increasing the pressure, the solubility of gas increases. So that means pressure of gas, or you can say the solubility of gas is directly proportional to the pressure applied. This is the, you can say, best way to explain. That is, what does Henry law states? It states that solubility of gas in a given liquid is directly proportional to the pressure applied. That means more is the pressure applied, more gas is going to dissolve in the given solvent, that is in a given liquid, right? So if we just solve it like this, so we have solubility directly proportional to the pressure exerted, or we can write it is directly proportional to this, removing this proportionality sign, we put constant Kh, and you know what is Kh? Obviously it is a Henry constant. It is a Henry constant, right? So as we know that solubility is always in moles per liter, and the pressure is in atmosphere, so we can just find the unit for Henry constant also. So this is actually is the Henry law. So what does it state? It states that the solubility of gas is directly proportional to the pressure applied. So if we draw a graph for it, so what we'll get? Suppose I have a pressure this side, this solubility we can take in terms of mole fraction as well. We can take in terms of moles, molarity as well, we can take in terms of mole fraction as well. So suppose I am taking in terms of mole fraction, that is X. So what kind of graph do I get to see? What kind of graph do I get to see? I get to see a straight line. That means the solubility, or you can say the mole fraction which get dissolved in the given solvent just increase when we increase the pressure. So this is what is a Henry law. And you have to keep in mind that under what condition this Henry law is actually applicable. This Henry law is, I am just going to write them up, and you also write in your copies that under what condition do you get to see this Henry law, you can say applicable. It is applicable only at the condition of equilibrium. It is applicable in the condition of equilibrium. Second, it is not applicable at high pressure. It is not applicable at high pressure. And moreover, it is not applicable where the chemical reaction is taking place. Because when the chemical reaction is taking place, it leads to formation of some other compound. So that means the moles might change, right? So that means the properties of the substance might change. So that means whether in the state where the chemical reaction is taking place, this Henry law is not applicable, right? It is applicable only to dilute solutions. It is applicable only to dilute solutions. So you have to keep in mind that under what condition this Henry law can be applied. So it can be applied obviously in the equilibrium condition, not at high pressure, and not at that place where the chemical reaction is taking place. That means some compound is formed with different properties, or it is applicable in the case of dilute solution. And as far as this Kh is concerned, it is a function of temperature. It is a function of temperature. That means if you increase the temperature, KH is also going to increase. So this is what is the Henry law. It is just trying to explain you that how the solubility of gas gets affected when you dissolve the gas in a given liquid, that is the solvent, right. Now the pressure factor we have already done, so let us focus on the temperature factor. That what is the effect of temperature on the solubility of gas in liquid. So what happens, I will just explain you again with an example. Suppose I have a container in which I have a water. I am just heating it. So when you heat the flask containing the water, what you get to see? You get to see the bubbles coming out. You get to see the bubbles coming out. Let us make the bubbles with red. You get to see that some bubbles are stick to the flask. You get to see some bubbles are just moving out. So that means what are those bubbles actually? They are nothing but the gas. So you can say when we increase the temperature, the solubility of gas just gets decreased. So this is the common example which you see at home when you just boil the water or boil anything. So when you boil anything, when you are supplying the temperature, then the solubility of gas is getting affected. How? It is decreasing with time, and this you can see that the gas is just escaping, because what happens when you supply them temperature, their kinetic energy actually increase, right, their force of attraction decrease and their motion obviously increase. So that is why they have the tendency to escape. So this is what they are doing here, they are just escaping out in the form of bubbles. So we can say that on increasing the pressure, the solubility of gas will increase, but on increasing the temperature, definitely the solubility of gas is going to decrease. So this is how the pressure and temperature plays an important role in the solubility of gas in liquid. As we did this Henry law, there are few applications, very important applications actually, which you get to see in the exam, which you get a question related to that what are the Henry law application, where is that Henry law being used. So you should know that this Henry law is used, you can say one of the applications is that when you are using a Coke bottle, it is tightly stoppered. So why you tightly stoppered that? We stoppered it because when we are increasing the pressure, the carbon dioxide or any gas, because we are talking about carbonated drink here, so that means this CO2 gas is getting highly soluble in the liquid content, right. So that is the reason that the Coke bottles are highly stoppered. And you know what is the one more example, one more Henry law application is the scuba divers. So what does that scuba divers actually do? You know that they have to dive deep into the sea. They have to dive deep into the sea. So let us make one scuba diver just to explain you. Let us make here. So this is our scuba diver. Right. So this is our scuba diver. So what he's going to do? So when suppose this is our surface. Right. So there is a normal pressure. But when we climb up, pressure actually decrease, and when we go down, the pressure actually increase. Right. So that means the scuba diver has a tendency to dive deep into the sea, right. This is what are called as scuba divers. So what happens when they go down, what happens? The pressure increases to a large extent. Pressure increases to a large extent. So what happens? The N2 gas, O2 gas, mostly the N2 and O2, these gases gets highly dissolved in the blood. These gases gets highly dissolved in the blood. As I told you that when the pressure increase, the solubility of gas increase, right. So what happens when they dive deep, the pressure obviously is going to increase, because when we are going to the depth, the pressure is increasing, right. So that means the pressure increase, this N2 and O2 get highly soluble in water, right, in their blood. So what happens when they come up, when they are scuba divers, when they come up, so what happens when they come up, the pressure suddenly falls down. Pressure suddenly start falling down. So when that pressure suddenly start falling down, so that means their solubility of these N2 and O2 gas is also decreasing. So that means the N2 and O2 gas start coming out in the form of bubbles. Right, again I am going to tell you, see when he is diving down, pressure is going to increase, so that means the solubility of gas is going to increase. So this is what the N2 and O2 gas are getting highly soluble in his blood. But when he is coming up, the pressure is going to fall suddenly, it will start falling suddenly. So what happens when it will fall, the solubility of these gases are going to decrease, these gases are going to come out from his blood in the form of bubbles. So what happens when they start coming out in the form of bubbles, sometimes they block the capillaries. Sometimes they block the capillaries, that cause bends in their capillaries, and you know that this can be a fatal also. That means it can also cause the death of the person, right. So this is the reason that they carry the cylinders with them containing the helium gas, nitrogen gas and oxygen gas in order to just resist this kind of condition, right. So this is the reason they carry the cylinders with themselves. Now one more application is that when climber climb mountains, so let us see, this is a plain, these are mountains, this is a sea inside. So this is a normal pressure. We know that when we go down the pressure increase and when we go up the pressure decrease. Suppose here is my climber, he is just trying to climb the mountain. So here is my climber going up. So what happens when the climber is going up, so that means pressure is decreasing. Pressure is decreasing. Pressure decreasing means that when he is climbing up, that means the solubility of gas is somehow decreasing. Because when the pressure decreases, we know that when the pressure decreases, the solubility obviously get affected in the same way. So pressure is decreasing, that means the solubility of gas is decreasing, right. So when he is trying to climb up, he is going up and up again. So that means the pressure is again going down, and as the pressure is going down, that means the solubility of O2 gas in blood is going down. That means there is hardly left any oxygen in his blood which he can use to respire or something like that. So what happens in that case? There is a condition called anoxia. There is a condition called anoxia. What is that? In this state, the climber just you can say lose its ability to think, right, because he becomes deprived of the oxygen. So this is also one of the application which is based on the Henry law. And one more application is there is the aquatic warming. See what happens as there is a global warming. As you all know that what is global warming, that is the increase in the temperature of the environment due to certain gases which get accumulated in the gas molecules, right. So what happens when infrared rays get accumulated in the gas molecules, they somehow increase the temperature of the atmosphere. That is what we call as global warming. So when there is global warming, so that means temperature is increasing. So I will write when global warming is increasing, temperature is increasing. And as we know that when temperature increase, solubility decrease. We did in this thing. We did here that when we increase the temperature, the solubility just decrease. We did in this thing. Right. So this is what happens, what we see in the aquatic bodies, that when the global warming increase, when the temperature increase, the solubility of gas decrease. So that means the dissolved oxygen start coming out. This dissolved oxygen of water starts coming out. So what who is going to get affected? Obviously the aquatic animals, right. They will be deprived, the water bodies will be deprived of oxygen, and those aquatic animals will hardly get oxygen to respire. So that means it will cause a kind of harm to them. So this is what we call as aquatic harming. So this is what is the Henry law. It is very important part of this chapter, and the applications also we did for scuba divers, the climbers, the aquatic warming. These are all very important. So just keep in mind, go through it once and then start just try to write in your own words. And this is what is that. Now we are going to start with the another.